Oh, the coin looks like a planet spinning on its own axis.
Oh yeah, anyway, speaking of planets, have you ever wondered how planets orbit around the sun?
Well, it all began with this brilliant scientist named Johannes Kepler. He was a German mathematician and astronomer who founded the theory of celestial mechanics and was the first astronomer to explain planetary motion.
Kepler also contributed to important theories in geometry and optics. However, his main body of work was in astronomy and planetary motion.
He was born in Walderstadt, Germany on the 28th of December 1571. At a very young age, he devoted himself to astronomy.
Kepler was a sickly child and his parents were very poor. His father was a mercenary soldier who left the family when Johannes was only 5, and his mother was a healer and a herbalist.
But through his intelligence and determination, he was able to acquire a scholarship at a university, which introduced him to the ideas of Copernicus. And by age 23, he took a teaching position in mathematics and astronomy at a Protestant school in Graz.
Fun fact, Kepler witnessed 2 astronomical events that spurred his interest in the cosmos. These events were the Great Comet of 1577 and a total lunar eclipse in 1580.
At the time, just about everybody followed Ptolemy's model of the universe, which states that the Earth was at the center and that everything, including the sun, moon, planets, etc., revolved around it. But Kepler agreed with Nicholas Copernicus, who said that the center of the galaxy was the sun and not the Earth.
Kepler was one of the first scientists to publicly support and explain Copernicus' theory. At that time, this idea was controversial because it went against centuries of belief that Earth was the center of everything.
Later, Kepler expanded on that theory by discovering his 3 laws of planetary motion, which mathematically describe how planets actually move around the sun, not in perfect circles but in elliptical orbits.
Kepler's first law, the law of elliptical orbits, states that planets move in elliptical paths around the sun. With the sun located at one of the foci of the ellipse and is not in the exact middle, this contradicted the prevailing belief in perfect circular orbits.
Kepler's second law, the law of equal areas, states that a line segment connecting a planet with the sun sweeps out equal areas at equal times. This law explains the varying speeds at which planets move in their orbits, faster when closer to the sun and slower when farther away.
Kepler's third law, the law of harmonies, establishes a relationship between the planet's orbital period and its average distance from the sun. Kepler's law of planetary motion changed astronomy and gave us a new understanding of the universe. He made these discoveries without the benefit of advanced telescopes or space exploration.
Additionally, he also advanced optics by designing the Keplerian telescope, which used convex lenses for higher magnification and clearer views, compared to Galileo's. This design became the foundation for future refracting telescopes.
But even though Kepler's works were very advanced and scientific for his time, he also practiced and believed in astrology, which was considered a more mystical belief system since it tries to predict the future and understand human behavior based on the positions of the stars and planets.
In his 40s, Kepler suddenly switched careers and became a lawyer, not for fame but to defend his own mother, Katharina Kepler, who had been accused of witchcraft, which was a very serious charge back then, by the way.
Unfortunately, in November of 1630, Johannes Kepler passed away at age 58 from a brief illness while on a trip to Regensburg, Germany.
Kepler's work forever changed astronomy, laying the foundation for modern science with his laws of planetary motion.
His legacy as a brilliant mathematician and astronomer continues to inspire and guide generations of scientists in their pursuit of knowledge about the universe.
And that's all we have for Johannes Kepler. Until next time!